Just a quick reminder to parents here. Please log into Parent View to register your children for the upcoming year. It looks like we'll be heading back to school by the time the fall comes around, but even if there's a delay, we all need to be registered for whatever sort of education it is we'll be doing. So take care of that as soon as you can. And now, on to today's lesson. To access your iReady lesson, simply go to myaps.edu and click on the iReady icon. If you haven't already done so, please install the login extension. Once you're in, you'll want to click Math, since that's what we're doing today. And you'll see two types of lessons as usual, My Path and Teacher Assigned. Try to do both, but if you only have time for one, try to prioritize the Teacher Assigned lesson. From this point onward, you know the routine. After you're done with that, go to the Student Resources folder and click on the Prodigy Math game. To log in, you'll want to use your Google account, and this is your APS Google account that begins with 9800, not a personal home account. Then, once you're in, you'll be asked whether you're playing from home or school.
Are you playing from home or from school?
You'll want to click Home, choose your world, and then begin your adventure.
Who are you? Oh, I gotta fight with the meow meow! No! Wait, two meow meows? Okay, since there's two opponents, I'm gonna use Star Cluster. 19, I think. Oh no. Oh, I was correct! Yeah! How do you like them apples? Woohoo! Power bonus! Tinyger. Oh, because he's tiny and he's a tiger. Star Cluster. 199. 199. How do you like them apples? Woohoo! But you get the idea of Prodigy, right? After I'm done with this battle, just log out, say bye, and make sure to like and subscribe as well. Multiply 45 times 10. That's easy. Yes. 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 Ooh, you're done. I only started last. You're level 6. You're amazing. Did I get any copper coins? No, but I got 200. 20 hot hots and 200 gold coins. Let's go. Let's get more stars. I got more than 100. Okay. Anyways.
Hi, this is Dr. Adam, and as usual, I'm joined today by and we're going to review some mathematical concepts today. We're going to start by talking about rounding, and then we're going to go on to review mathematical factors of 10, and we will conclude with fractions. So let's go ahead and get started with that by talking about rounding. Now here we have a 10 rod, and the reason it is a 10 rod is because it is literally equal to 10 units. Let's try counting that. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10.
10 of those individual yellow blocks is the exact same length as this
green rod.
Green rod.
10 rod.
This green 10 rod, exactly. So we're going to talk about tens, and we'll count tens. This is using 10 as a factor in multiplication. We have one 10, it's 10. Two tens is
20, obviously. 30, 40, 50, 60, 70, 80, 90, and 100.
Now once we get to 100, we can really just replace it with this square right here, which represents 100.
Yes, this blue square equal to 100 yellow units. It might not look like much if you don't count, but if you count, it's exactly 100.
And we can show that right here. So here we saw that this 10 rod is equal to 10 of these individual yellow units. Well, here's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
Right.
It is equal to 10 of the 10 rods.
Which equals 100 because 10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
And that's what we call 110 squared because it literally makes the shape of a square. And if we were to get 100 times 10, 100, 200, 300, 400, 500, 600, 700, 800, 900,
1,000.
1,000 is called a cube because it literally makes the shape of a cube.
It's cube.
All right, so let's step back a little bit just to the tens. And we have 3 tens, which is
30.
And 4 tens, which is
40.
And I want to think of a number that is in between them. So I'm going to choose the number 32. To make 32, we have 3 tens and 2 units. Now the question is 32 closer to 30 or is it closer to 40? Well, it depends on how much distance we have to travel to turn this 32 into 30 or to turn it into 40. In order to turn 32 into 30, we just have to knock off 2 units. But if we want to turn 32 into 40, we have to add 1, 2,
8,
3,
obviously.
4, 5, 6, 7, 8 units.
I was right.
That was a lot more work adding 8 units to it.
Then just taking away 2 units.
Mm-hmm. And if we think about that as one being further than the other, just think of what it's like to walk 2 steps versus what it's like to walk 8 steps. Let's walk 2 steps. 1, 2.
Now let's walk 8 steps. 1, 2, 3, 4, 5, 6, 7, 8. It goes onto the keyboard.
That's right. We traveled a much further distance walking 8 steps than we did walking 2 steps. So we could say that 32, because it's only 2 steps away, is closer to 30 than it is to the gargantuan path it has to travel to get to 40.
Okay.
And when we talk about this number being closer to this tens group of 30 than it is to this tens group of 40, we call that rounding off. We just take these extra pieces and just even it out so it ends with a 0 like that, and it's much closer to 30 than it is to 40. Now, inversely, if the number is not 32 but 38, is 38 closer to 30 or is it closer to 40? Well, in order for 38 to become 40, we simply have to travel how many steps?
2 steps.
2 steps by adding 2. Now, if we want to turn it into 30, we have to travel a much longer distance of 1,
2, 3, 4, 5, 6, 7, 8.
To travel 8 steps by removing 8 of these. So clearly, the shorter distance is between 38 and 40, not between 38 and 30. So in this case, we would round up to 40.
Not round down to 30.
Because it would take a lot more work to remove these 8 than it would to add these little 2 onto it.
Mm-hmm.
Now, the question arises, what about when you're at 5? 5 is exactly half of 10. So if 5 is exactly half of 10, do we round up to 10 or we round down to 0? Well, let's take 35 right here.
Smack dab in the middle.
Smack dab in the middle. So if we wanted to turn into 40, we would have to add 5. 1, 2, 3, 4, 5. And if we wanted to turn it into 30, we would take away 5. 1, 2, 3, 4, 5. So the question is, what does it round to? Does it round up to 40, or does it round down to 30? So the tradition is, pretty much until you're in the 12th grade, it rounds up. Whenever you're at 5, smack dab in the middle, you round up to the nearest 10. So 35 would round up to 40. That's the only case where you can't see which one is closer with your eyes using blocks. You just have to know that 5 always rounds up to the nearest 10. Okay, let's take a look at a very, very closely related concept, which is 10 as a factor in multiplication. So we know how multiplication works. So here we have the number 3. And I'm seeing 3 how many times? How many times do I see 3 there?
Only 1. Let's say you want to do by 2 or 3 or 4, etc., etc.
Okay. What number do we see here?
3.
How many times do we see it?
1.
So we would say
1 times 3.
Now, how many times do we see 3?
We see it 2 times. So now we say 2 times 3.
Okay. Now we see 3.
3 times. So we say 3 times 3.
And how many times do we see 3 now?
4 times. So we say 4 times 3.
Good. So we say 4 times 3. And 4 times 3, if we want to count it, would be 12. But of course, if we're good with our times tables, we can just kind of figure that out. 3, 6, 9, 12.
Okay. So the product for each of these is 3, 6, 9, 12.
Right. Now, we know that this block equals 10 because we just talked about it and showed it and measured it. Well, what if we see 10 2 times? It is now 2 times 10, which equals 20. How many times do we see 10 now?
We see it 3 times.
So it is 3 times 10, which equals
30.
4 times 10, which equals
40.
5 times 10, which equals
50.
6 times 10, which equals
60.
7 times 10, which equals
70.
8 times 10, which equals
80.
9 times 10, which equals
90.
and 10 times 10, which equals
100.
Okay, so the cool thing about these numbers, when you multiply by 10, is they're just like regular numbers, but they have an extra 0 after them. So we have normal numbers like 1 and 2 and 3 and 4 and 5
and 6 and 7.
And when we multiply them by 10, here's 10, add a 0. Here's 20, add a 0 to 2. 30, add a 0 to 3. 40, add a 0 to 4. 50, add a 0 to 5. 60, add a 0 to 6. And 70, add a 0 to 7.
So basically what happened is why those numbers got changed to their 10 forms is because, well, they're multiplied by 10. So basically, the concept is, if you multiply anything by 10, as it is the same number but with an extra 0.
Very good.
Here we multiplied 1-digit numbers by 10. You would think, what happens when we multiply 2-digit numbers by 10? By like 25. Well, we simply add extra zeros to them. So 25 times 10 obviously equals 250.
Okay, so 25
That's basically
times 10. 250 right there. I want to help us visualize this with the manipulative blocks here. So let's take this idea. Here is this number we had, 3. But we're going to do 3 times 10. Well, so it's not 3 units now, it's 3 tens bars. Whatever we would normally have of this, we now have tens bars instead of unit blocks. So let's take one of those bigger numbers like 13.
Little tiny baby unit blocks compared to these giant rods.
Okay, let's take this right here. So how many unit blocks do we have here?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Okay, 13. So if we wanted to multiply 13 by 10, each one of these unit blocks would be replaced by a 10 bar.
Yep. So basically, what 13 times 10 would be, you already got this in your mind, it's probably 130.
So we can count each of these individual pieces. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We shouldn't have to do that. We should know how to count, skip count, but we should know how to skip count by tens by now. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So if we take the number we started with, which is 13, and we simply add a 0 to the end, which is kind of the trick we were talking about, we've seen that that works because we turned each one of those 13 unit blocks into 13 10 bars, and we did end up coming up with a number which was 13 with an extra 0 after it.
Very much.
And that is one of the ways I want us to continue thinking about multiplying with a factor of 10. Now, the area I wanted us to close out with is fractions.
I love using these fraction circles for fraction practice.
They are very, very useful. Very messy, too.
Yep.
But
especially the 12s.
Especially the 12ths. Yeah, the 12ths are very tiny. Okay. So, of course, we know that this is a whole number. This is a whole pizza that no one has cut up yet to divide it. And here is
half a pizza.
Half a pizza. Now, if there were just 2 of us sharing a pizza, like if me and Dina were sharing a pizza, we'd probably cut it into
2 parts,
which we would call
halves.
Now, here is something called a third. Now, the question is a third bigger or smaller than a half?
With your eyes, you could clearly see that a third is smaller than a half.
Now, you might be wondering why something with 2 on the bottom of it is bigger than something with 3 on the bottom of it. Well, this number at the bottom of the fraction, the denominator, works in the opposite direction of regular numbers. So yes, it's true. In regular numbers, 3 is a bigger number than 2. But in fractions, it's the opposite. Having a third at the bottom of the fraction makes it a smaller number than if you have a 2 at the bottom. And the same happens the bigger the number you go. Having a 4 at the bottom of it
makes it even smaller than a third.
Than if you have a 3 at the bottom. This is the opposite of regular numbers, where the regular number 4 is bigger than the regular number 3. But in fractions, a 4 is smaller than a third. And it continues that way with all the fractions. There's something called a fifth, which is smaller than a fourth, even though in regular numbers, 5 is bigger than 4. It's the opposite in fractions. A fifth is smaller than a fourth? And continuing in that direction,
we have a sixth. A sixth is clearly smaller than a fifth.
And it continues that way. Let's take something that has a really big number at the bottom, like a tenth. A tenth is way smaller than
first we
a sixth.
Go to eighths and then tenths. Sorry.
All right. A twelfth is even smaller than a tenth, because on fractions, the bigger the bottom number, the smaller the size. 12th compared to a third. So, now we want to talk about comparing these fractions. Well, in regular numbers, what is the connection between 6 on the one hand and 12 on the other hand? Let's go ahead and see. Here we have the number 6. Here we have the number 12. Now there's a very special relationship that 6 has with 12. These aren't just two random numbers. 6 is exactly...
6 is exactly half of 12.
6 is exactly half of 12.
It's pretty obvious.
So, if fractions are kind of the opposite of regular numbers, 6, which is exactly twice as small as 12 in regular numbers.
In fractions, the 12th is actually twice as small as the 6th.
That's right. A sixth
Which is very weird.
A sixth is twice as big as a 12th in fractions. The same relation of one being twice as big as the other is reversed in fractions. It takes 2/12 to make a sixth, just like in regular numbers, it takes 2 6s to make 12.
Except it's the complete opposite.
It's the complete opposite. When the big number is on the bottom of that fraction, the denominator, you have the opposite relation that you have to numbers in the regular sense outside of fractions.
But there is a chance that the smaller number may actually be bigger than the larger number if there's a bigger numerator. Now you might be asking, what's a numerator? It's not the bottom of the fraction, it's the top. The top of the fraction actually is like real numbers. The bigger the numerator, the bigger the number gets. Like it. Here's 1/12, and then you want to up the numerator to 2. Now we have 2/12.
Very good. Okay, now let's see why these are called what they're called. Why is this called a third? Why is this called a sixth?
Well, obviously because of the denominator.
The answer is that you need how many thirds to make a whole pizza?
Well, it is 3.
3. 3 thirds make one whole pizza. How many sixths do you need to make a whole pizza? Does 3 sixths make a whole pizza just like 3 thirds does?
Nope, it makes half.
It makes half.
Probably because 2 sixths, probably because a sixth is half of a third.
That's right, and that's the opposite of the relationship we're used to. Normally we think of 3 being twice as small as 6. In the regular world of numbers, it takes 2 3s to make a 6. But in fractions, it takes 2 sixths to make a third. So a sixth is twice as small as a third, not twice as big, like it is with 6 being twice as big as 3. So just as you need 3 thirds to make a complete pizza, you need 6 sixths to make a complete pizza.
And it's the same with all the other numbers, the tenths, the eighths, the 12th, the 5th, etc., etc.
So we'd like to thank you for joining us today for this review of rounding, 10 as a factor in multiplication, and fractions.
Like to support Duran's Elementary, subscribe to get notified whenever this channel uploads a video.
Thank you. Bye-bye.
Okay, so that's the end of the video. Like and subscribe.